Right, today we're going to talk about graphs of radical equations. If you remember, the parent function is y equals the square root of x. This is the most basic radical equation, so that's why it's called the parent function. And then vertex form of a radical equation is y equals a times the square root of x minus h and then plus k, where h and k are your vertex. If you need to pause this for a minute to write it down, go right ahead. All right, we're going to look at an example on how to graph a radical equation. We're going to start by looking at the vertex. So our h and our k. The k is written on this side of the radical instead of the right side, but that's okay. So opposite h, so 1, negative 5, that's our vertex. So we can go ahead and put that point on here. And then we can make a table and quickly find some other points to put on here. All right, so we know this is a square root equation or a radical equation, and the quickest way to graph that is to just look at some points. We already know the vertex is 1, negative 5. We're not going to put anything less than 1 because if I do, for instance, 0 minus 1 is a negative number. And remember, a square root of a negative is an imaginary number, and we're not graphing imaginary numbers. We're just graphing the square root of this real radical equation. So we're going to start by looking at a couple points here. So let's put 2. 2 minus 1 is 1. The square root of 1 is 1, times 2 is 2, and 2 plus negative 5 is negative 3. So that one worked out nice because it gave us the square root of 1, which is a perfect square. Our next perfect square, and just to make this easy to graph, I'm going to try to make this into a perfect square each time. So I know that 2 squared is 4. So in order for this number to be 4, I have to have 5 as my x. 5 minus 1 is 4. So let's choose 5. And you can choose any x's you want. If you want to deal with fractions or square roots, that's fine. I'm trying to pick numbers that are easy to evaluate. So 5 minus 1 is 4. Square root of 4 is 2. 2 times 2 is 4. And 4 plus negative 5 is negative 1. All right, so my next perfect square is 9. So the square root of 9 is 3, so I need this number to be 9. So I'm going to choose 10 as my x. 10 minus 1 is 9. The square root of 9 is 3. 3 times 2 is 6. 6 plus negative 5 is 1. So let's graph these and see what we have. So we're going to have 2 and negative 3. 5 and negative 1. And then 10 is going to be on out here a little bit and then up 1. All right, so I'm going to sketch this. Maybe. Okay, so it should look like this, just shifted over. I'm not very good at drawing here on the computer. All right, so that's how you would sketch a graph using transformations, and this is a radical equation. While we're looking at this, let's go ahead and quickly find the domain and range because that is one of our standards that we have to review quite often. All right, so the domain is all of our x's. So if we look, it starts at positive 1, okay? If I can draw a line down through here to show, it starts at positive 1, so our domain will be the set of x's greater than or equal to 1. And then our range is our y values. And if we look, our y values are everything above this lowest point, which would be y is greater than or equal to -5. And if you look, you can see that that comes from your vertex, your domain, and your range from a radical equation will come from your vertex point. All right, let's look at one more. All right, if we look at number 2, first thing we want to do is look at the vertex. So our h is inside our radical. There's no h here, so that's going to be 0. And our k is -2. So that's going to be our vertex, so 0, -2. And then again, if I create a table of values, that makes it easy to substitute numbers in and solve. All right, so we can put 1 in here. Square root of 1 is 1. 1 times 2 is 2. 2 plus -2 is 0. So 1, 0 is a point. And then I want a perfect square here. So again, you can choose any number you want to plug in. I'm just trying to make it nice, easy numbers to graph. So I'm going to choose 4 as my x because I know the square root of 4 is 2. 2 times 2 is 4. 4 minus 2 is 2. And then let's choose one more point. So let's choose 9 because 9 is a perfect square. Square root of 9 is 3. 3 times 2 is 6. 6 minus 2 is 4. All right, so I've already graphed the first 2 points. If I look at 4, 2, and I come out here to 9 and 4. And then again, I'm just going to start at the vertex and draw my curve. Hopefully you guys can draw your curve a little bit better than me. All right, let's look at domain and range really quick. Your domain comes from your x values. If you look at your x values, they start at 0, so it's going to be all x's greater than or equal to 0. If we look at our y's, it starts at -2 and goes up, so it's going to be all y's greater than or equal to -2. All right, I hope this helps you understand how to graph radical equations a little bit.